Okay, so this is the first problem for the free response question that we did in class. So it has A, B, C, D, and E. For A, it's asking to find the translational kinetic energy of the sphere when it reaches the bottom of the inclined plane. So you know that your GPH or GPE, or your gravitational potential energy, is equal to your kinetic energy, right? Energy at the top is equal to energy at the bottom. So you have your MGH is equal to your 1/2 mv squared, because that's your kinetic energy, plus your 1/2 IW squared, which is your rotational kinetic energy. Now you have to substitute in several things into this equation. You have your MGH is equal to your 1/2 mv squared, that doesn't change, but then you can substitute things in for I and W. So in the problem, it says that I is 2/5 mr squared. So you substitute that in, and you end up substituting in W, which is your velocity of rotation, which ends up being V over R squared, because that is what W is equal to, is V over R. So now you need to add those together, and you get your mg squared, or MGH is equal to 1/2 mv squared plus 1/5, because that is 1/2 times 2/5, so 1/5 mv squared. You end up, your r squared is canceled out because there's an r squared there and there's an r squared there. That's where you get your mv squared from. So now, in order to find what this is, these are the same, so you can add those together. You need to end up finding the lowest common denominator, so doing some simple math, you get MGH is equal to 7 mv squared over 10, and that's what your lowest common denominator between 1/2 and 1/5 is, doing it simplified. So now you have your m's cancel out because they're the same for both. You end up, you need to solve for v squared. So your v squared ends up being, if you do all this together, 10 times gh, 10 gh over 7, because there's your 7. So, oh my goodness, with that, you have to substitute this in. So your K translational is equal to your 1/2 mv squared, or your kinetic energy is, you substitute 10 over 7 in for v squared. So then you end up with 5 over 7 mgh, because you end up doing, like, this cancels out, so you have 1/2 times 10 over 7 gh, which is from up here. Okay, so that is your answer for A, is this one. For B, you have, remember that your force is equal to ma. So what you end up doing for force is your torque. So here's your torque, remember, because torque is equal to force. So your equation for that is I acceleration. So again, you have to substitute stuff in. So your acceleration is equal to acceleration over your radius. So your torque is actually equal to, what's making your torque spin is your force of friction, right? We talked about that in class. So you do that times your radius, because in your problem it says that it is not slipping. So you have force there if it's not slipping. So your force of friction is, you substitute that in, times your radius, because that's what your torque is equal to your 2/5 mr squared, because they gave you that in the problem, and then you substitute in for your acceleration, your a over r. So your force of friction is actually equal to, since that cancels out with one of those, and then that cancels out with this one, so you end up with 2/5 ma. Mass and acceleration. So now you have to put in your sum of all forces equation. So your sum of all forces, so your frictional force in this case is, or your force going downwards, sorry. Your force going downwards is mg sine of theta. Remember, because you're going downwards in this equation. Minus your force of friction, because that's your sum of all equations. If you have your thing here, you do this minus this. So you're going downwards minus your force of friction is equal to ma. Now, you have this because you just solved for that up here. So you have your mg sine of theta minus 2/5 ma, because you just solved for that up here, is equal to ma again, because that's this equation right here. So your m's cancel out because they're all the same. So you end up with g sine of theta minus 2/5 is equal to a. Now B is asking for your rotational kinetic energy at the bottom. So you end up your rotational kinetic energy, if you look at this equation, it's GPE is equal to KE minus R, or plus RKE, right? We learned that from the beginning. So now in order to get RKE on its own, you have to do GPE minus KE is equal to RKE. So you end up putting stuff in for that, and you get MGH minus your KE was 5/7 MGH, which is up here. So your RKE ends up being equal to 2/7 MGH, because you can look at this as this is 1 minus 5/7 equals 2/7. So this is your answer for B. Now for C, you ended up, it's asking for the acceleration. So you found what this was. You found that your g sine of theta was minus 2/5 is equal to ma, which you end up crossing off all the m's. And in order to get this a on its own, because there's an a here, sorry, I didn't put that down. There's an a here and there's an a here. You'd have to add your 2/5 over here. So you'd end up with g sine of theta is equal to 7/5 a, and then to get your a alone, it would end up being, you'd have to inverse this, so it's 5/7 g sine of theta, and that would be your answer to C when you're looking for acceleration. So D then, your force of friction, I'll put this over here, is equal to, we found this up here, your force of friction is equal to 2/5 ma. So you plug that in down here. And then you found out what A was. So you have to substitute this in for right here. So you have 2/5, and then you still have M, and then you have your 5/7 g sine of theta. And that ends up being equal to, if you multiply these two together, find the lowest common denominator, you end up getting 2/7 mg sine of theta for D. Now for E, it's asking you when the solid sphere is replaced with a hollow sphere of identical mass and radius, how would it change the result? So what your K value is, they give it to you for your uniform sphere, it was 2/5. You automatically know, since it's a hollow sphere, like a complete hollow sphere with nothing in the center is 1, right? Your K would equal 1. So you know that a hollow sphere has to be greater than 2/5, because this is a uniform sphere, this has to be greater than that. So basically you know that your rotational kinetic energy is greater as a hollow sphere than it is as a solid sphere. So it will be moving slower because your kinetic energy is greater. you actually, if you knew this ahead of time, your K for a holosphere is actually 2/3. So your K is 2/3, so that means that your RK would be greater. So that's it. I will do the next one in just a second.